Given question, find out first normal stress and shear stress along oblique plane AB. Second, principal stress and location of principal planes. Third, maximum shear stress and position of maximum shear stress. To find out the parameters for the given diagram, let us first understand the sign convention. We will understand the sign convention for the tensile stress. So we will show the stress with the arrow in the outward direction from the body. And we will show the stress with positive sign. Now we will move to the compressive stress. We will show the compressive stress with the arrow towards the body. For compressive stress, we will use the negative sign. Now we will move to the shear stress. There are two types. So we will first understand the direction of stress which will act at this face. So when the direction at this face is in the upward direction, then we have to show the direction on the opposite face is opposite to this direction, that is in the downward direction. Now if I move the compass in the direction of these two arrows, then it will be in anti-clockwise. And for this anti-clockwise direction, we will use the positive sign. Now the shear stresses are in complementary form. So if we observe the arrow, this arrow is pointing towards this point. So for this face, if I show the shear stress, so shear stress always parallel to the face. So if I draw one line parallel to this face, then we have to show arrow directing towards this point. Now if we observe this shear stress having direction towards this point. So if I draw line parallel to this face, then I have to show direction towards this point. So if the arrows are in these directions, then there is anti-clockwise direction, and for this anti-clockwise direction we have to use positive sign. Now we will move to the second type. So we have to always concentrate on the shear stress at this face. Now we will use the shear stress at this face is in the opposite direction, that is in the downward direction. Now this is the opposite face, so we have to show shear stress in the opposite direction. Now if I move the compass in the direction of these two shear stress, then it is in clockwise direction, and we will use the negative sign. Now shear stresses are in complementary form. Now if we observe here, the direction of arrow is pointing towards this point. So if I show the shear stress along this face, if I draw here one horizontal line, then I have to show direction of arrow towards this point. Now in the same way, this shear stress is pointing towards this point. So if I draw horizontal line for this face, then I have to show direction of arrow towards this point. Now for this type of shear stress, we have to use the negative sign. Now with reference to the sign convention, we will observe the given diagram. Now along the horizontal line, 50 megapascal force is acting, and it is the tensile stress. So here this tensile stress we have to show with positive sign, and it is along the horizontal line. So we will use the notation sigma x. So I will write here sigma x is equal to plus 50 megapascal. Now if we observe along the vertical line, there is 10 megapascal stress, and it is towards the body, that is it is the compressive stress. So it is along the vertical direction, so we will use here the letter sigma y, and which is equal to minus 10 megapascal. Now if we observe the shear stress, then this is the face which is important. At this face, direction of arrow is the upward direction. That means here is anti-clockwise direction and we have to use positive sign. So shear stress tau is equal to plus 40 megapascal. We will calculate normal stress and shear stress along the oblique plane AB. For normal stress along AB, we will use sigma NAB is equal to, its a formula is sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos of 2 theta plus tau xy sin of 2 theta. Now sigma x is mentioned in the question, that is plus 50 megapascal, sigma y is minus 10 megapascal, tau xy, that is the shear stress given in the diagram, it is plus 40 megapascal. Now what about this angle theta? So angle theta is the angle made by the oblique plane. So I will show here, suppose this is our given body, then here is the oblique plane. Then angle theta is the angle made by this oblique plane AB with this vertical line in anti-clockwise direction. So from this line we have to measure this angle in the anti-clockwise direction, and this is known as angle theta. Now if we observe the given diagram, then this angle theta is equal to 30 degree. So 2 theta is equal to 60 degree. So we will put the value 50 minus 10 by 2 plus 50 minus 10 by 2 cos of 60 plus tau xy is 40 sin of 60. Now when we calculate this, we will get the value 69.64 megapascal. Now it is having positive sign. So this type of stress is the tensile stress and it is normal to the oblique plane. Now we will move to calculate the shear stress along the plane AB. So we will use the notation tau AB and its a formula is minus inside the bracket sigma x minus sigma y by 2 sin of 2 theta plus tau cos of 2 theta. So here tau xy, that is the shear stress given in the question. Now if we multiply this minus sign inside the bracket, then it will become minus sigma x plus sigma y by 2. Then sin of 2 theta, that is sin 60 plus 40 cos of 60. Now we have to put the value. So here minus 50 plus minus 10, that is minus 50 minus 10 by 2 sin 60, that is 0.86 plus here 40 cos 60 is 20. So answer is minus 5.8 megapascal. So here for the shear stress negative sign is given. So we have to show the shear stress along the oblique plane in the downward direction because of this negative sign. We will understand how to show this normal stress as well as shear stress. So normal stress, that means stress perpendicular to this oblique plane AB. So I will draw one perpendicular line and which is in the outward direction. Because of positive sign we have to show the stress is the tensile stress, and we will show here that is 69.64 megapascal. Now we will show the shear stress. So shear stress is along this oblique plane, but here the sign is negative. So we have to use the arrow which is in the downward direction. So here is the downward direction. So because of negative sign, we will show here the arrow in the downward direction. Now if we show the arrow in the downward direction, we have to show only magnitude, and that is 5.8 megapascal. We will calculate principal stress and location of principal planes. For principal stress, we will get two values. So we will write sigma P1, sigma P2 is equal to sigma x plus sigma y by 2 plus minus under root of sigma x minus sigma y by 2 square plus tau xy square. So we have values sigma x plus 50, sigma y minus 10, tau xy plus 40. We will put these values. So how to get the two values? So here 50 minus 10 by 2 is equal to 20, plus minus, if we solve this bracket we will get 50. So we get first value as 20 plus 50, that is equal to 70 megapascal, and we will get second value 20 minus 50, that is minus 30 megapascal. Now we will find out the location of principal planes. So this location we will measure in terms of angle theta p. So we have formula for 2 theta p is equal to tan inverse of 2 tau xy by sigma x minus sigma y. So when we put the value, so we will get tan inverse of 80 by 60. So when we calculate this, then we will get the angle 53.13 degree. So this is the angle in the first quadrant. So we will get the second angle as 53.13 plus 180. So that is we get the two angles. So this is first angle, and when we add 180, then we get the second angle. So first angle is 53.13 degree. And second angle 233.13 degree. Now this is the value for 2 theta p, but actual we want theta p. So we will divide these angles by 2. So answer is theta p is equal to first angle 26.56 degree and second angle 116.56 degree. Now if we observe the stresses, then the maximum stress we have to show at the first angle, that is 26.56 degree, and minimum stress we have to show at the second angle. Now we will locate principal stress and principal planes. So principal plane is at an angle 26.56 degree. So we will measure this angle from this vertical face, so in anti-clockwise direction. So I will draw here one line at an angle 26.56 degree in anti-clockwise direction. Now second angle is 116.56 degree and it is greater than 90 degree. So how to locate this angle? So I will extend this vertical line and I will measure this angle from this vertical construction line. So angle from this vertical line and horizontal line is 90 degree and remaining angle is again 26.56 degree. So I will draw here one line. So this total angle in anti-clockwise direction is 116.56 degree. Now here is the point of intersection, and if we observe the angle between these two construction lines is 90 degree, that means these two lines are perpendicular to each other. Now I will highlight some area of this line from this point of intersection. Now I will draw parallel line for these two lines. Now we have to show 70 megapascal at 26.56 degree. So this is the line for 26.56 degree and 70 megapascal is with positive sign. So we have to show in the form of tensile stress. And we have to show it is equal to 70 megapascal. Now second, minus 30 megapascal at 116.56. So this is the line at an angle 116.56. So it is having minus sign. So we have to show this in terms of compressive stress. Now when we show the compressive stress with the help of arrow, so we have to mention here only magnitude, that is 30 megapascal. Now we will calculate maximum shear stress and position of maximum shear stress. We have formula tau max is equal to plus minus under root of sigma x minus sigma y 2 bracket square plus tau xy square. So if we observe the formula for the principal stress, then we have to take here the second part of that formula. which is equal to plus minus, we will put the value sigma x is plus 50, sigma y is minus 10 and tau xy is plus 40. So we will get the answer. Here is plus minus sign, that is plus 50 and minus 50. So we will get these two values. So this plus 50 is the maximum value. Now we will move to the position of this maximum shear stress. So we will measure this position in terms of angle theta. So we have formula, that is in terms of 2 theta s. So 2 theta s is equal to tan inverse of minus sigma x minus sigma y divided by 2 tau xy. So when we put the values, then we will get tan inverse of minus sigma x plus sigma y divided by 2 tau xy. We will multiply this minus sign inside the bracket. Now we will put the value. Tan inverse of minus 50 plus minus 10, that is it will become minus 10. Minus 50 minus 10 divided by 2 into 40. So we will get minus 60 divided by 80. So we will take this minus sign outside. So tan inverse of 60 by 80 is 36.86. So here already negative sign is there. So minus 36.86 is the first angle, and which is in the first quadrant. So how to take the second angle? We have to just add 180. So when we add this 180, we will get the second angle 143.13 degree. But this is the value for 2 theta s. We want the value of theta s. So we will divide with 2. So first angle is minus 18.43. So this is the first angle. And 71.56 is the second angle. Now to locate the shear stress, we have to show the maximum value at the first angle and remaining minimum value at the second angle. Now we will locate the maximum shear stress. So if we observe, the first angle is having negative sign. So we always show the angle from this vertical line in anti-clockwise direction. So when the angle with positive sign, we will use the anti-clockwise direction, but here the sign is negative. That means we have to use the opposite direction, that is clockwise direction. So we have to take the angle 18.43 in clockwise direction from this vertical line. So I will show here this construction line, and this angle is equal to 18.43 degree. But this line is outside the body. So we will take the same line with inside the body. So this line, if I show here, if I take the parallel line, then it should pass through this point. Then if I extend this vertical line, then here this inclined line is also making an angle equal to 18.43 degree with this vertical line. So these two are parallel line, and this is the common vertical line. So these two angles are same. So this is the first line. Now we will move to the second position. So it is at an angle 71.56 degree. So it is positive angle. So from this vertical line, we will mark the line at an angle 71.56 degree. I will show here. So this angle is 71.56 degree. Now if we observe this point of intersection, at this point of intersection, these two lines making an angle 90 degree. Now I will highlight some area from this point of intersection. So I will highlight along this construction line, and I will highlight along this construction line. Now for these two lines, I will also draw another two parallel lines. So for this line, I will show here line parallel to this, and for this line, I will show here this is the parallel line. Now if we observe, we have to show this stress, that is the maximum shear stress. So at angle 18.43, so this is the line at an angle 18.43. So for at this line we have to show plus 50 megapascal. So it is having plus sign. So we have to show this in terms of tensile stress. That is the direction in the outward direction because of the positive magnitude. And we will show here 50 megapascal. Now for minus 50 megapascal we have to use the line which is inclined at an angle 71.56. So these two lines. So here is minus sign. So we have to show the compressive stress. So direction of arrow towards the body. Now we have to show only magnitude because we have shown here the compressive stress. So we will write here 50 megapascal.